Evaluate the limit as x approaches infinity of 7 minus 6x to the fifth divided by x plus 3. So here, first off, before we go into the algebra, what will we expect as x becomes a very large positive number for this expression to approach? Well, in the numerator, you can see the only thing that concerns with x is this negative 6x to the fifth. And right, as x becomes very large positive, x to the fifth is going to be a huge positive number. Like say x is 1,000, then x to the fifth is going to be 1,000 to the fifth power. That's like over a trillion, actually. What is it? 100, 1,000 trillion, huge number. And when you have put that negative sign in front, it's going to become negative that ginormous number. And so in the numerator, it's going to approach a large negative number. And the denominator, you can see, well, we only have a linear x term. So we'll say when x is 1,000, all we have is 1,000 plus 3. And so the numerator, and that x to the fifth term, is x is a lot larger than that x term, right? When x is 1,000, this is 1,000 to the fifth, whereas this is just 1,000, right? It's actually 1,000 to the 4 times as large. And so in the numerator, we say we have a large negative number, and in the denominator, we have a relatively small positive number. And so large negative divided by small positive gives us in total a large negative number. And so we would say this probably approaches negative infinity. Let's figure that out algebraically. So here we have the limit as x approaches infinity, but what I'm going to do is I'm going to divide by the highest power in the denominator. And this works for a lot of rational limits. Divide by the highest power in the denominator. In this case, just 1, right? Linear term, x to the first power. So I divide everything by x, and let's do some simplification. 6x to the fifth divided by x is just 6x to the fourth, and x divided by x is 1. And so now, again, we have a limit as x approaches infinity of this quotient, and we can apply the properties that the limit of a quotient of two things is the quotient of the limit. So I'm going to take the limit as x approaches infinity of the numerator and then divide it by the limit as x approaches infinity of the denominator and then see what those two things are. So let's do that. As we take a look at the first term, 7 over x, as x gets very large positive, this number is going to approach 0, right? Because say as x is a million, 7 over a million, that's very small. 7 over a billion, that's even smaller. 7 over a trillion, it's going to approach 0. This term, similarly to how we set up here, as x gets a very large positive, x to the fourth is a very large positive number, but we have a negative sign in front, so it's going to become a very large negative number. And it's going to keep increasing, right? X to the fourth, right? Remember that parabola, right? It just keeps on increasing without bound up to positive infinity. But in this case, it's downwards because it's a negative infinity. And so the numerator is going to approach negative infinity. Now, what about the denominator? Well, as x approaches infinity, 1 doesn't change based on x. But 3 over x, similar to 7 over x, it's going to approach 0, right? Because as x gets, say, 1,000, 3 over 1,000 is very small. As x goes to a million, 3 over a million is even smaller, and it's going to approach 0. And so we can say that this is equal to negative infinity divided by 1, which is negative infinity.